All right, before we jump into today to 8, I want to really quickly make a very quick kind of adjustment change to our notes from 2-7. So on page 137 of your notes, yesterday I said an equation is proportional if it's in y equals mx plus b. Please add to your notes and the b is 0. Okay, the b has to be 0 for it to be proportional. For a graph, yes, it is a straight line, but also it has to go through the point or start from the point 0, 0. So please add the 2 parts in red there because that is actually what makes it a proportional relationship. Both of these are linear, the way I had them written, but they're not linear and proportional. You have to add the red part to get proportional. Okay, now we are moving on to our new notes, which is 2-8. And I hadn't erased it yet. Let me erase this really quickly. So 2-8 starts on page 139, and we're actually not going to work that problem on 139. We're going to use the space to do a little memory reminding of some terminology that we've talked about so far. All right. So here is what we're going to talk about today. Okay. And notice that the title of today's lesson is Understanding the Y-intercept of a Line. You guys have really already dealt with the Y-intercept, but every single one of our Y-intercepts up to this point has been 0, 0 or 0. It's gone through the origin or started from the origin. Okay. We're going to today, we're going to introduce a little bit more. We're just going to add to that, and we're going to have lines that don't go through the origin. Okay. All right. So everybody should be writing this down. Please, everybody, on page 139, write down y equals mx plus b. The m is the slope. The b is the y-intercept. Okay? Obviously not in class, but the first person that comes into class and tell me why the b is used for y-intercept, I'll give you a piece of candy tomorrow. Okay? Because I don't know. Research it and figure it out. If you let me know, I'll give you candy. All right. So this is, you don't necessarily have to draw this. This is just for me to talk to you. So far, we have dealt with everything like our green line, right? So our green line goes right through the origin, and you could even have it start at the origin. It doesn't have to go all the way through. It can even start at the origin. And that's everything we've done so far, and the b is 0. What we're going to talk about today is examples like the red and the purple line. If you notice the red line, it's still a straight line, but it passes through the y-intercept, and the y-intercept is, I have it highlighted in blue. That's your up and down axis. Your y-axis, the red line, intercepts it up higher than the origin, and I called it 0.5 just because I was just kind of hand sketching the graph. So my b here, or my y-intercept, or my beginning point, however you want to think about it, is 5. The purple point, the y-intercept, is at -5. Okay, so the b in this case would be -5. So if I showed you an equation, and if I did not have this right here already written, right? If I did not give you the b equals -5, the b equals 0, and the b equals +5, and I just wrote an equation and said y equals 3x minus 5, and I said, which colored line could this possibly go to? Well, the way you would identify it is you would look at the b, which is -5, and you would pick the graph that crosses the y-axis down at the -5. Okay, so in this case, this equation would go with the purple thing. This equation right here would go with the purple line. And I know that because I look at the y-intercept, okay? And that tells me it can't be the green one and it can't be the red one because they don't have the right intercept. Yes. What was under the, oh, I'm sorry, slope. Yep, you're good, slope. Make sense? All right, so what we're gonna do today is we're just gonna be adding a little bit to what we've already learned about the y-intercept. And now they're not always going to be through 0. Some of them still will be, and that's okay, but some of them won't be. Okay? Are we good? All right, let's look at example number 1. And this is actually the example that got me thinking about my error on proportional. All right, so it says Mathilde, why don't they just use words like Beth? It would be so much easier. Mathilde, I don't know, and her friend are going bowling. She can rent shoes at the bowling alley or use her mom's old bowling shoes. How can she determine how much money she will save if she brings her mother's old bowling shoes? So it says, what pattern can you see in the cost of the different numbers of games? So the first thing I want to do is, this is bowling prices, and it says that it includes shoe rental. Okay. So whatever price is quoted here, it includes shoe rental. So I'm going to do a couple of things here. The first thing I want to do is I want to identify what's the X and what's the Y. Okay. Because in all these tables and graphs that we're given, they're all over the place. Sometimes they're on the left, sometimes they're on the right, sometimes they're on the top, sometimes they're on the bottom. You have to kind of have a way of figuring out which one is X and which one is Y. The best way I can tell you is look for the one that can be reduced to a unit of 1. Okay. And kind of, it really, the games already are. You've got in your table 1 game, 3 games, 5 games, 10 games, right? That's the unit that you can reduce to a 1. So that is what would be considered our X here. I will tell you, just as a loose rule, your money's pretty much always going to be your Y. When you're doing speed, your distance is always going to be your Y. Okay. So you just have to kind of look at the problem, look at what each what each column is representing. This column over here is representing number of games. This column is representing money spent. So the number of games is going to be that unit that you can get down to a 1. Okay. So I really don't have a better way to tell you. I wish I did, but I don't. All right. The other thing I want to do is I want to write these, and we're going to use this information in a minute. I want to write this as an ordered pair. So for 1 game, that's my X, I'm going to pay $4. That's my Y. I'm going to write this as an ordered pair. If I buy 3 games, I'm going to write this as the ordered pair 8 or 3-8. If I buy 5 games, it's $12. So that creates that ordered pair. And then 10 games is $22. And that creates that ordered pair. That's one thing I'm going to do with this. The other thing I'm going to do with this is I want to see if it's proportional. Okay. And we know how to do that. We take our Y divided by our X for each point. So our Y divided by our X is 4. So if we buy 1 game, it's going to cost us $4. $4 each, right? $4 per game. If we spend $8, we're going to get 3 games, and that comes out to 2.66666. Since we're talking money, I'm going to round it to 2.67 because money always is dollars and cents. That means if you buy 3 games, you're going to pay $2.67 per game. Okay, hang on. I'm going to pause this for just 1 second. Now we're going to find the proportion of $12 spent for 5 games. And that comes out to 2.4. And I'm going to put 2.40 because, again, I'm talking money here. So if you buy 5 games, you're going to spend $2.40 per game. And then last, if you buy 10 games, you spend $22. Whoops, did that backwards. Sorry. Put my X on top. $22, 10 games. That is $2.20 each. So is this proportional? No. So that tells us that the B is not 0. So that means, think about what the B is. It's your y-intercept. Your Y is your money. So that means that you're not going to be at that 0.00, which means if you buy 0 games, you're not going to be at $0 because it's not on the graph, right? So it doesn't work. It's not proportional. So that means that we're going to start out, even before we buy 1 game, we're going to start out spending money. And that money that we spend obviously has to go towards the shoes because that's the constant that you're going to pay no matter how many games you buy. Okay. So let's look at what they have us do. So step 1 is they have us plot all those points. Okay. So I'm just going to do them here so I can talk about them color coded. So the 0.14 I'll do in red. 0.38 in blue. All right, so here are our 3 points, 4 points that we were given, and they graphed them, okay? And they drew a straight line. Now, notice that my line does not actually touch the y-axis. Again, as a reminder, here's our y-axis. That's kind of the important thing here. That's our y-intercept or our y-axis. Our line doesn't quite get there, and so we need it to get there. Now, there's a it's close enough here. You could probably eyeball it, hand draw it, and be right. But if it's not as close to the y-axis as this is, what are the chances? Remember on our jump start when I said I added extra points so I could get a nice, good, accurate line? I want to get a nice, good, accurate line because I want to accurately know where my line crosses the y-axis. And if I hand draw it and guess, I may not be accurate. So let's do it mathematically. In order to add more points, I need a what? Always, always. I need to rise over a run or a fall, right? I need to know how to move. So I need a slope, an M. Yes, I need to know my M. Now they give it to us here. They figure it's rise over run and they get 2/1. Okay. So I'm just going to use their work. They get 2/1 as the M right here. 2/1. Okay. That's the slope. Now we did it in the jump start. Could I say that -2 over -1 is still a positive slope, right? Positive, negative goes positive. So I'm good. So I can either rise to and go to the right one, that's positive, positive, or I can fall to and go backwards one, and that's negative, negative, and I'm still okay because I'm still on my positive slope. Okay, so let's look at our graph. Now I want to do it wrong first so I can help you catch this error, and then I'll do it right. So don't write this part down because I'm going to do it wrong first on purpose. I know that sounds crazy, but it helps. If I say I'm falling 2 and running 1, and I say I'm going to fall 2 boxes and run 1 box, and I stick a point here, does that point line up with where I think my line should cross? No. Does anybody see what I did wrong? What'd I do? Exactly. I went by the boxes and not the units. I fell 2 boxes. Boxes don't matter. Okay, so let's undo that and let's do it the right way. I need to fill in some gaps here. So I need to know that, right, if this is 0 and this is 4, I need to know that halfway in the middle is a 2. And I don't really need to know this. Yeah, I do. I'll put a 1 there. Okay. So from my red point, which is the first point I have, if I now from that point fall 2 units, not boxes, if I fall 2 units, that's 1, 2, and then I run 1 unit, which does happen to be 1 full box this time because 1 whole box is 1. So I fall 2, I run 1, and I land on my y-axis. Now, can I very accurately add a little to my line and see that my line crosses the y-axis at what? At 2. Yeah, good. And that's actually, you're leading into my next, so I'm going to call on you next. All right, so I can say that my y-intercept is 2. Now, what is my y-axis dealing with? You got to look at the graph. It's dealing money, right? So that means that I walk in the door. My initial money I spend before I ever buy a game, I spend $2. And that's on shoes, right? Or you could even like say you're going someplace and they charge a cover charge, right? So just to walk in the door, they charge you $5 and then you buy stuff while you're there. So your initial investment or your initial start is not at 0, 0, it's at 2 because you have to buy shoes no matter how many games you play. So if you walk in the door and you're going to buy 0 games, you're going to spend $2. And then if you move up from there, right, you're still going to spend that $2 on shoes, but your game price is going to change. All right. Now I want to lead into, I asked what that point was and Jordan said what? 0, 2. I want you to know this because you've got to pay attention to what your homework is asking. If it simply says, what is the y-intercept? You're just going to simply put the number 2. That's it. If it says, what are the coordinates or what is the point of the y-intercept? You're going to put in the coordinate 0, 2. And for every single y-intercept, it doesn't matter where it's on the graph, what's always going to be 0? My x. The x will always be 0 in an intercept. Why? Because for it to sit right on the y-axis, it can't move left or right. It can't have a left or right movement. So the x is always going to be 0. No matter if it's a high y-intercept, right at the 0, or a low intercept, the x value is always going to be 0 because they never move left or right. Okay? Good with that? All right. So this is just basically showing what we just did, which was we extended our line. So I'm not going to go over that. We literally just did it. and it says the line crosses the axis at, and there's the point where it crosses. Okay, so again, if it just asks the y-intercept, look right here. The answer is the y-intercept is 2. Then it says what's the coordinate? That's when you would put it as an ordered pair XY. Okay, and again, you have to be able to interpret what that means. That means that when you walk in the door, your initial investment is $2 right off the bat before you've ever bought a game. So that means that's the price of the shoes or the price of entry. Okay. All right. So now we're going to try it. So we are going to look at our graph, and this one's nice. We don't even have to extend it. It's already extended, and it already reaches our y-intercept or our y-axis, right? As a refresher, here's your y-axis. What did it do that for? I turned off my heater and my screen went blank. I like it. There we go. Thank you, guys. The y-axis, right? That's what we care about here. And we want to know, where does our line touch the y-axis? So I'm going to put a point right where my line touches the y-axis. Now I have to figure out where that's at. So it takes a little bit of filling in here, but we can do that. If this is 0 and this is 4, half of that is 2. And we actually need half of that because that's where our point is. And so we need to fill in 3. Okay, so our y-intercept, and I'm going to do it backwards because I like to. Our y-intercept is here. What would I put here? 3, right? And then my ordered pair is what goes here. And I know the y value is a 3. And what do I know every x value is going to be? 0. Yep. Okay. And then it says, for these examples, why does the y-intercept represent the cost of renting bowling shoes? We've already talked about that. Don't worry about writing it. We've already talked about it. If it's a homework assignment, then you would actually write it out in words, what we've already said. Okay. Are we good with that? Remember that your y-intercept is where your line crosses the y-axis. Okay. Hint, hint. That's one of your homework questions. All right. So now example 2 says the y-intercept of a proportional relationship. Well, let's check to see if it's proportional. And you gotta love Savas, but this table, why does it make me twitch? Y's are on top, but that's okay. We're getting smart enough that we can figure it out. Our time in minutes, that's what that's what we could reduce to a 1 and get it a unit rate. So we're gonna leave that as our x. So if we create a proportion with our y's on top, 12 over 1 reduces to 12. What's 36 over 3 reduced to? 60 over 5, 96 over 8. So is this proportional? So what is our b or our y-intercept? 0. Beautiful. Okay. I'm glad we went back and fixed my error. The graph backs it up. Okay. When we graph it, we find our slope. And from here to here, we go down 1 over 2. If we go down 1 over, oh, that didn't work. Oh, that's because that wasn't the slope. Okay, sorry. The slope here is 12. So that means we go down 12 over 1, down 12 over 1. And when we end up doing that, we would land here. Now, do we have to do the work of down 12 over 1, down 12 over 1, down 12 over 1 to know that our b is going to end up at 0? No. If it's proportional, you know you're going to end up at 0. You know your b is going to be 0. And if I was to say write an equation for this, which it doesn't really ask you to, but we're just going to do it to practice, it's y equals what? 12x. Good. We know it's plus 0, but we don't have to write it. Okay? Beautiful. Okay, let's move on to example 3. Example 3 says, okay, we're given a graph, and it says, what is the y-intercept for each of these linear relationships shown? Okay, don't overthink this. It really is this easy. Okay, remember, we're just caring about our y-axis. Okay, and we just want to put a point where our line crosses it. So our line, the blue line, crosses our axis right there. So our y-intercept is 2. And if it says what's the intercept, you just put in the you put in the number 2. If it says what are the coordinates or what is the point of the y-intercept, you would put what? 0, 2. Okay, so just the y-axis is just the y. The point is 0 and then the y. All right. How about this one? Got to fill in a little bit of gap here. If this is 0 and this is -2, what's this one? -1. That is right where our point crosses. So the y-intercept is -1. If I want to write it as a point, 0, -1. Okay. All right. So try it. This one, just like the example, so pretty easy. Our line crosses the y-axis right there. Put a point there. And then it says, what is the y-intercept of each graph? So our answer is going to be 2. Okay, that is where our line crosses the y-axis. Okay, how about this one? Does it matter that it's negative and that it's a decimal? Nope. Still put a point there. That is still the point, -0.5. I'm not real picky about this 0. If you want to put it, put it. If you don't, don't. Okay. And if I want to write it as an ordered pair, I would write 0, -0.5. Okay. No matter what your y is, exactly how it's written here is exactly what you put in the ordered pair. All right. That is it. Okay. So for your homework, hang on, don't put your book away because I want you to mark out a few. For your homework, you are going to do pages 143 and 144, but I want you to mark off 13 or 12 and 13. Okay, 12 we're going to talk about together. You can try 12 if you want, but it's not required. And then 13, I'm going to do a little bit of research and I'm going to figure out what an additive inverse is, and then we'll talk about it tomorrow. Okay. That would make sense to me. And that was kind of because inverse means opposite. So that makes sense to me. And that's probably what I'm going to find, but I want to make sure before we do it. Okay. So skip number 12 and number 13, do the rest of them, and you will be set. For those of you at home, make sure you take notes in your notebook and then email me if you have any questions.